Alright, in section 1-3, we are going to deal with a couple things. First thing we're going to deal with is slope of a line, and then after that we're going to deal with how to come up with equations of lines, and then also some parallel and perpendicular stuff. First thing we're going to talk about is slope. Now what slope is the grade of the line, or the pitch, or whatever. Those are some common terms that we use in everyday life when we're talking about pitch of a roof or grade of a road. But slope is something that we use in lines, and when we see slope in the line itself, we see it as the lowercase m. It's commonly referred to as rise over run, which the rise number is the number that goes up and down, and the run number is how far it goes to the right. And also we have a formula for it if that's the other way that you guys want to find it. So there's a couple different ways. One of the ways that you can do it is you can actually find it by plotting the ordered pairs and how do you go from left to right, or you can put it in the formula and go from there. So the two different points that we're going to use is we're going to use the point 2, 1 and 8, 5. Now if we were to graph those, I'd make a set of axes, important to label them just so you know where you're going, and then plot your ordered pairs. So 2, 1 is letter P, and then 2, 3, 4, 5, 6, 7, 8, and up 1, 2, 3, 4, 5, 8, 5. That is letter Q. Now what you'd want to do is you'd want to go, okay, from P, which is the left point, to the Q, which is the right point, how would you get there? Well, you go up so far and over so far. Well, how far up was 4, and how far over was 6. So my rise number was 4, my run number was 6. That reduces down to 2/3, and we're done. Now the rise number could also be negative had the left point been higher than the lower point, or the right point. So just so that you do know that you could have slopes that are positive or negative. The other way that we could do this is if I were to label this as x1 and y1, and then this is x2 and y2, is using the formula. So 5 minus 1 over 8 minus 2. On the top, 5 minus 1 is 4. On the bottom, 8 minus 2 is 6, which ends up reducing down to 2/3 also. So those are the two different ways that you can find slope. These are positive slopes because if I were to connect from P to Q, I would be going up the hill, which would be positive. If I was going downhill, that would have been a negative slope. If I was going horizontally, that would be a 0 slope. And if I'm going straight vertical, that's a no slope is what we call that. And the reason why it's a no slope is because if you were to do the formula, you'd be dividing by 0, and you can't do that. Okay? So that's how you're going to find slope anyway for those two things. Then the second thing that we're going to do is we're going to deal with how to come up with equations of lines. Now the first thing that I'm going to go through is slope-intercept form. What slope-intercept form is it's kind of the form that we use nowadays because of the invention of the graphing calculator. We use it so much now. It's y equals mx plus b, where m is the slope and b is the y-intercept. That's where it crosses the y-axis. Okay. The other form that we use is point slope. Now realistically, it does not matter whichever formula you use in order to come up with your equation. Because either one will give you the same answer, and I'll show you that here in just a second. But what this one is, and I was told when I was growing up that this is used if you have the slope, which again that's lowercase m, and if they give you an ordered pair. These 2 points are your point. That's what you should use. However, now going up, I prefer to use slope-intercept, but it's totally up to you as far as how you attack the problem and find the problem or find the solution. So those are the two forms that we're going to go through. I'm going to give you an example of both of them, and actually I'm going to use the same points and do the same thing just so that you can see it's going to come out with the same answer, and it doesn't matter which one you choose. So the ordered pairs I'm going to use are -1, 2, and then 3 and -4. Now I'm showing you one that gives you 2 ordered pairs, and the reason for that is because this one actually requires you to do an additional step that some of the other ones don't. If they give you a slope and an intercept, or slope and a point, then you don't need to find the slope, it's already given to you. However, there are times when they don't give you the slope. Then the first thing you need to do is find the slope. So negative 4 minus 2, and all I'm doing is that same slope formula that we had before, and 3 minus a negative 1. Well, right here, these two right there back to back should turn that into one big positive. And I end up having negative 6 on the top over 4, which reduces down to negative 3 over 2. So there's my slope. Now I'm going to do this two ways, and it's up to you to decide whichever way you like best. First way I'm going to do is using y equals mx plus b. Now when I have this here, I actually give you an x and I give you a y, and then we just found the m. So the only thing you don't know is you don't know b. So I'm going to plug in the 2 for the y. I'm going to put negative 3 halves in for the m. I'm going to put the negative 1 in for the x, and you don't know b. And that's what our goal is to try to find. So the first thing is you multiply the negative 3 halves times the negative 1, which would give you positive 3 over 2 plus b. Now subtract 3 over 2 to both sides because you're solving for b. And now when you subtract a whole number from a fraction like that, or vice versa, you got to get a common denominator if you don't know the answer. So for that particular thing, 2 would be 2 over 1. You multiply both things by 2 to give me 4 over 2 minus 3 over 2, which would end up being 1/2. Okay? So my final answer for this is y equals negative 3 over 2x plus 1/2. Now the reason why it was plus 1/2 like that is because, or why I have it as y and x again, is because if I were to put the 2 and the negative 1 back in there, that would end up giving me just a point, not an equation of a line like we want. Okay, so be very careful with that. A lot of people try to put the y and the x in there, but no, that's just a certain point on your line, not an actual line. The other way that I'm going to do it is using the formula, or using the point slope formula. And when you're doing this, what we're going to do is this is x1 and this is y1. Now realistically it was not when we did it with when we found the slope. However, I'm just proving a point to you that it doesn't matter which equation you use, and it doesn't matter what point you use either. So I have y minus negative 4 equals negative 3 halves times x minus 3. First thing that happens, this turns into a plus. So I have y plus 4. And then this needs to be distributed, which ends up being negative 3 halves x minus 9 halves. And when you multiply that, it's top times the top and bottom times the bottom. Then you subtract 4 over to both sides. This would have been a plus right there. See how it happens when you go too fast, you forget about the sign. Then I'd have y equals negative 3 halves x. And then again, finding a common denominator, 4 over 1 would be negative 8 over 2, and 9 minus 8 is again 1/2. So I did this to show you that it doesn't matter necessarily what point you use or what formula you use, you're going to get the same thing regardless of whichever way you do it. And now that's when you're given 2 points. Again, if they give you a point and a slope, or a slope and an intercept, plug them in and go to town. You don't need to find the slope. But if they don't give you the slope, you'll find that first. Okay? From there, if they give you the equation y equals negative 3 over 2x plus 1/2, they might want you to put it in what they call standard form. Now standard form is just a form that is kind of what they started with, where they have the x and y on one side and the letter on the other, or the number on the other side. Key to this is there can be no fractions when you're dealing with this, so we're going to have to multiply something to get rid of it. And the second thing that would happen is x is positive. Okay, so for this particular thing, we've got some issues. We have fractions in here, x and y is not on the same side, so let's start by getting rid of the fractions first. I'm going to multiply everything by 2. Now the reason why I'm multiplying everything by 2 is that 2 is the common denominator between both my bottoms. So what's 2 times y? 2y. 2 times negative 3 halves x is negative 3x. And 2 times 1/2 would be 1. Now I don't have any fractions. The next thing that I want to do is I want to add 3x to both sides. I'm trying to get the x and y on the same side rather than on opposite sides. So 3x plus 2y equals 1. And as long as my x is positive, then we are done. If it's not positive, then I multiply everything by a negative 1. that changes all the signs and essentially gives me an x to be positive. The reason why I think they do this is that they want you to have the lead thing to be a positive number rather than a negative. I've also seen it where the c is also on the same side, where they subtract the 1 over, and it would all be the same. So anyway, that's how you get it in the standard form. Unfortunately, if you are just given two ordered pairs and you are asked to put it in standard form, you would have to go through one of the other two forms first in order to get it into standard form. You got to do all that other work too. So just so that you are aware of it, that's what's going to have to happen. The next thing I want to show you is if you do have it in standard form like that, one of the things that we can do is we can graph this a couple different ways. One of them is we could stick it into our graphing calculator, but the other way is to just do it by hand. Now, when you graph ones like this, the main thing is we start at the y-intercept, or the b. So I'm going to go up a half and make a dot. Then the slope is going to give us the direction of where to go. That says -3 over 2, which means I'm going to go down 3 to the right 2. So I'm just going to make a couple extra marks just so that I have some basis to go on. So 1, 2, 3, and then over 1, 2, and I make a dot. Now, for a line, all you need is two ordered pairs or two dots like that, and then you connect them, and you are done. You have graphed your line, and so that way you didn't have to make a bunch of extra marks or whatever. The other thing is that you could put this into a graphing calculator as it looks, as long as it's in slope-intercept form, and it will also graph it for you. If you need be, you can go down another 3 spots again and then over 2, and you would be right on the line also. So just so that you are aware of it, those are some things to look for. The last thing that we have to deal with is parallel versus perpendicular. Now, what parallel means is where the lines are running side by side and they have the same slope, they never touch. And they have different y-intercepts. When you see a thing for that, you'll see kind of almost like an 11 down there, but that means slope of the parallel is equal to your slope that you're given. So on that last one, where we had a slope of -3/2, the slope of the parallel would also be -3/2. The difference being the y-intercepts would be a different y-intercept. Perpendicular means that you're going to make a 90-degree corner when two lines intersect. When it comes to algebra, we see an upside down capital T for that. And what they do is they give you this. And a lot of times what people see is they see this and they don't know what that means in symbol-wise. What that stands for is it stands for opposite reciprocal. Okay, that's what that means. It's an opposite reciprocal. So if your original slope is -3/2, the slope of the perpendicular, you'd flip over the 3/2 and you'd also change the sign to a positive, would be 2/3. Okay, so just so that you know, that's how we do that. Now, what's going to happen is they're going to give you an equation or give you a scenario that says find an equation that goes through the point 5, 2 and is parallel to 4x plus 6y plus 5 equals 0. Now this is the key thing right there. Is I said parallel for this one. It could say perpendicular or whatever, but just so that you know is that this is how it's gonna look. From here, the line that they give you, we need to solve for y, and the reason why we do that is so that we can take the slope out of it. So I'm going to subtract 4x to both sides. So I get 6y equals -4x plus 5, and then I'm going to divide by 6 to everything. Now realistically, the only thing I'm really focusing on is what the slope is. I don't really care what this other one is because they're not going to ask us to graph it. I'm only mainly focused on that -2/3. That's the thing that I really care about in this problem. So now that I have the slope, since it was parallel, I'm going to use the same slope. If it was perpendicular, I would have flipped it over and changed the sign and made it 3/2. So just so that we're aware of it, the slope is going to be the same when it comes to parallel. When it would have been perpendicular, I would have flipped it over and changed the sign. Now, me personally, I like to use the y equals mx plus b. So 2 is going to go in for y. -2/3 is going in for m. 5 is going in for x, and I don't know b. So the first thing I do is I multiply that together, which makes negative 10 over 3. Again, you go straight across the top, and then you add 10 thirds to both sides. And one more time, we need to make sure that we have a common denominator, and the common denominator for that is 3. So I multiply the top by 3 and the bottom by 3, and I'd end up with 16 thirds when I'd add it together. So my final equation is y equals negative 2/3 x plus 16 thirds. And that's my equation of my line. Now, had it said standard form, multiply everything by 3, add the 2x over, and I would have 2x plus 3y equals 16. And I have the same equation. So just so that you are aware of it, sometimes they'll switch that around and say parallel versus perpendicular. Some of the directions will say determine whether the lines are parallel or perpendicular, and if they do that, all you're looking at is the slopes. Are the slopes the same? Yes or no? Are they opposite reciprocals? Yes or no? If they're not at 90 and above, then they're not either one of those. So that should be about it for this section. Hope that helped. See you later. Bye.